Hello guys, this is Edexcel Science channel. Now we are at question number 12. A student has a spring of length 0.18 meters. The spring has a stiffness constant of 25 Newton per meter. The student applies a force of 7 Newton to stretch the spring. Calculate the new length of the spring. So this is my original length. And this is the force that is being applied. Now, whenever you have a force and the spring's constant, always remember that the formula that you have to use is the Hooke's law formula, which is F equals K times extension. K is the spring's constant over here. So to find out the new length, what we have to do is we need to find out how much extension has the spring experienced. So del x is equals F divided by K, 7 divided by 0.18, which would be 0.28 meters. So if initially it was 7 meters, if initially it was 0.18 meters, now it has been extended 0.28 meters. So to find out the new length, all we have to do is add both of them. So new length is 0.18 added with 0.28, which should be 0.46 meters. Moving on to question number 13. A bicycle pedal is connected to a circular chain ring by a lever. A person of weight W stands on the pedal. So someone is standing over here and his weight is over here. The lever is at an angle theta to the horizontal as shown. So this is theta. It is with the horizontal. Determine the moment of W about the pivot when theta is 24. Okay, very good. Now, always remember that whenever the force is at an angle, to the object that is rotating, you have to find out the component of the force, and you have to take the component that is perpendicular to the rod or to the plank or anything that is rotating. I repeat, whenever there is a force that is at an angle with the object that is rotating, you have to find out the components of that force, and you have to use the component that is perpendicular to the plank, to the rod, whatever there is. Now, if we want to find out the component of weight, it should be this component. Now, if this is theta, we know that this is also going to be theta. And this is going to be W cos theta. So if we want to find out the moment that is caused by the force W, it is going to be W cos theta times the perpendicular distance, this distance. And this distance is the length of the lever, which is 0.21. So 580 cos 24 times 0.21 is going to be 111 Newton. This question looks complicated by the diagram, but in reality it is not. Question number B. The chain ring exerts a force F on the chain as shown. So this chain is actually exerting a force. Okay. This force is actually proportional to the moment of W. Okay, very good. So we can say that F is proportional to the moment of W. Okay, fine. Actually, moment of W, so it should be W cos theta times whatever, actually the length of the lever is 0.21. So it is saying that if you want to convert this sentence mathematically, it should be something like this, that the force is proportional to W cos 0.21. Now, explain how F changes as theta increases from 0 to 90. Now, if you know, if you look at this expression, right, what do you think is changing in this expression? This is not changing because this is a constant value. Weight is also not changing because it is also a constant value. So what we can say is that F is kind of like directly proportional to cos theta. You can say that. Now, if you know the diagram, the diagram of cos theta, it should be something like this. It looks very ugly, but let me try one more time. So it should be something like this, right? It should be something like this. So we can see that this is 90 degree, right? So we can actually ignore all this part. So if I draw it again, only the first part of the cos graph, we can see that this is 90 degree. And as the angle increases, the overall value of the curve decreases, right? So if this theta changes from 0 to 90 degree, the value of F should decrease. So how do we answer this question? Do we really need to show all of this in the exam? No, this is just for understanding. So the first point would be that if theta increases from 0 to 90, this component will decrease. So the component of W perpendicular to the lever decreases as theta increases from 0 to 90. That is why the moment, if the component itself, if this component decreases, that means the overall moment is also decreasing. So the moment of W also decreases. Therefore, F decreases. That is how we answer this question. In physics, it is always a good practice to remember the graph of cos and sine, because some of those questions, these questions are kind of repetitive.